the distance formula. So finding the distance between 2 points. Whenever we have points that are far apart, some of the things you need to understand is you can count the units. And so if I said this is your A and this is your B, we could find the distance between these 2 points if they're vertical or horizontal simply by counting the spaces between A and B. So we've got 1, 2, 3, 4, 5 spaces. So we would say that this is 5 units apart, or A to B in this case would be 5 units. The interesting case happens when they're kind of diagonal. In other words, what's the distance between that A and B, the black A and B? And so we had to figure out that distance, and we do know something that can help us figure that out. If I were to go from B and go straight up until I got level with A, and then from A I was going to go horizontal, you're going to notice that that creates a special triangle. That kind of triangle is called a right triangle. Hopefully you said that to yourself. And now I'm going to use, what do you think, the Pythagorean theorem to solve the distance between A and B. So the first thing I'm going to do is count the spaces that are vertical. Vertical is up and down. There are 2 spaces here, so that is 2 units. I count over 1, 2, 3, 4, 5 units on the top. And so now I can use the Pythagorean theorem to solve this. 5 and 2 are my legs, so 2 squared plus 5 squared is going to give me c squared. And again, c would be the distance from A to B. 2 squared just means 2 times 2, which is 4. 5 squared means 5 times 5, which is 25. That gives me c squared. So 29 is what c squared is. And then we take the square root of that, and the square root of 29 5.4, rounding to the nearest 10. So the distance between A and B, we would say, is 5.4 units away. Now we can put that on a coordinate grid, and again, you're finding the distance. We're going to label these points A and B. You're finding the distance the same way on the coordinate grid. You're going to notice that I do have a formula here, and we're going to talk about what that formula means in a little bit. But to find the diagonal distance between A and B, I'm going to find first the vertical distance and the horizontal distance. Now it doesn't matter if you go down first and to the right, or if you go up and to the right. So down and to the left or up and to the right. Either way, you get that box, and they both form right triangles. Make sure that you're going on that line. You don't want to be underneath it like I am. So make sure it's right on that line. And so now you're going to, again, count the spaces, not the lines, but count the spaces. So if I look at the bottom, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, and 1, 2, 3, 4 spaces on the side. Using that idea of the Pythagorean theorem, 9 squared plus 4 squared is equal to c squared. So 81 plus 16, c squared, 81 plus 16 gives me 97. Take the square root of that. So I get c equals 9.8 units rounded to the nearest 10. Now, of course, there's this formula that you see here. D equals the square root of x1 minus x2 squared, and added to y1 minus y2, that quantity squared. That's the idea that you can use instead of drawing it out, you can use this formula. This is more of the mathematical way. This point A is at -4, +2. B is at 5, 6. And so using the idea of this formula, this x sub 1 really means from the first point, y sub 1 means from the first point. So the first one, x sub 1, y sub 1, that's this point here. So I'm going to plug that in. -4 is plugged in, and 2 gets plugged in. Then I'm going to also plug in x2, y2, just means the second point. So we're going to subtract. x2 would have been 5, y2 is 6. And then I use the rules of math. -4 minus 5 gives me -9 squared, plus 2 minus 6 gives me -4 squared. Now you may be looking at those two numbers and thinking, I bet I've seen those before. 9 and 5, even though positive, were the lengths of those lines that we created. Now when I square each of those, -9 squared is 81, and -4 squared is 16. So I end up getting the same thing, the square root of 97, which we know is 9.8. So the distance is approximately, that's what those wavy equal signs mean, 9.8 units. And that's how you're going to use the distance formula. Some of you are going to really like the picture better. Some of you are going to like the distance formula. Let's look at the next one. We'll do it both ways again. Let's start off with the points. In this case, 2, 4 is point number 1. Point number 2, 1, 2, 3, 5, -3. So again, we're finding the distance. What's the distance between those 2 points? Using the distance formula, I'm just going to set it up, and then I'm going to plug my values in. So I'm going to start with the first point, 2 and 4. And I'm going to start with the second point, 5, -3. 2 minus 5 is -3, you have to square that. And 4 minus -3, which becomes 4 plus 3, ends up being 7. Take the square of those, -3 squared, 9, plus 7 squared, 49. Get the square root of 9 plus 49, 58. And the square root of 58 is approximately, and again, you need the wavy equal sign to show approximation, 7.6 units. That's the algebraic way. Let's look at that pictorial way. So we're going to put in our right triangle. Again, you have to have a vertical line, which is straight up and down, and a horizontal line, which is side to side. And then I'm going to count the units for each of those sides. The bottom, 3 spaces. The side, 1, 2, 3, 4, 5, 7 spaces. So again, 7 squared plus 3 squared equals c squared. 49 plus 9 equals c squared. 58 is equal to c squared. Take the square root of both sides. C is approximately 7.6. Either way will always work. So if you're given 2 points, for example in the next one, if you're given 2 points, You can draw those on the graph and find the distance, or you can use the distance formula. So let's start with the distance formula. I'll plug these numbers in. This is going to be my first x, so -3, and my first y is 8. The second one, 4 and 1, and now I solve that. -3 minus 4 gives me -7 squared. 8 minus 1 is 7 squared. -7 squared is 49. 7 squared is 49. So I get the square root of 98. And the square root of 98 is approximately 9.9 units. If we're going to use the graph paper that we'll have, and you can use this on the MCA test too, these are other questions that are on the MCA test. -3, +8 puts me right there. 4, 1, it's right there. So now the question is, what's the distance between those 2 points? Again, I want to have a vertical line that follows the lines on the graph paper and a horizontal line until they create that right triangle. Now I've got that right triangle, and let's count the spaces. 1, 2, 3, 4, 5, 6, 7 spaces on the right. 1, 2, 3, 4, 5, 6, 7 spaces on top. So again, I'm looking for that C. 7 squared plus 7 squared equals C squared. 49 plus 49 equals C squared. 98 equals C squared. Take the square root of both sides. So C is approximately 9.9. It doesn't matter which method you choose, as long as you get to the correct answer.